Welcome to the .NET Way. You're watching episode 17 of our .NET Core interview series. Today, we are diving into one of the most important backend architecture concepts in ASP.NET Core: background services and hosted services. These power schedulers, queue processors, recurring jobs, monitoring systems, notification pipelines, and enterprise automation workflows running behind the scenes in production applications. Let's find out from Aarohi how experienced developers use them safely and efficiently in real-world systems.
Thanks. Hosted services are one of the most powerful features in ASP.NET Core, but they're also one of the easiest places to create production problems. If developers implement them incorrectly, they can accidentally create memory leaks, duplicate processing, thread exhaustion, stuck jobs, or even silently broken background systems that fail without anyone noticing.
Aarohi, let's start with the basics. What exactly is a hosted service?
A hosted service is a long-running background process that runs independently from incoming HTTP requests. Unlike controllers, which only execute when users call APIs, hosted services start automatically when the application starts and continue running in the background until the application shuts down. In ASP.NET Core, they're implemented using either the IHostedService interface or the BackgroundService base class. They're extremely useful for automation, recurring tasks, monitoring systems, and asynchronous background processing.
Where do companies actually use them in production?
Almost everywhere. Enterprise applications commonly use hosted services for sending scheduled emails, processing RabbitMQ or Kafka queues, generating reports, syncing third-party APIs, processing uploaded files, monitoring systems, and running recurring cleanup jobs. Modern distributed systems rely heavily on background processing because not every operation should happen directly during an HTTP request. Hosted services help move expensive or recurring workloads away from the main API pipeline.
Can you show us the basic structure?
Usually, developers inherit from the background service base class and override execute async. Inside that method, we create a continuous loop that performs background work until the application shuts down. In this example, the worker checks for pending emails every few minutes and processes them automatically. Finally, we register the service using add hosted service, so ASP.NET Core starts it automatically during application startup.
Do they solve the same problem?
Yes, both are used for background processing. IHostedService is the lower-level interface that gives developers complete control using start async and stop async methods. BackgroundService is an abstract helper class built on top of IHostedService that simplifies the implementation by providing execute async. Most developers prefer BackgroundService because it reduces boilerplate code and creates cleaner worker implementations.
How does ASP.NET Core start these workers internally?
When the application host starts, ASP.NET Core resolves all registered hosted services from dependency injection and automatically calls start async on each one. For background service implementations, the framework internally launches execute async in the background using the thread pool. This entire lifecycle is managed automatically by the ASP.NET Core hosting infrastructure.
What happens during application shutdown?
ASP.NET Core sends a cancellation token to the worker during shutdown. Your code must respect that token by checking is cancellation requested and passing the token into delays, database calls, and HTTP requests. Otherwise, the application may terminate while jobs are still running, potentially causing corrupted data, half-completed operations, or inconsistent state. Graceful shutdown handling becomes extremely important in enterprise systems.
What if the worker needs repositories or APIs?
Absolutely. Hosted services fully support dependency injection, just like controllers and APIs. You can inject repositories, APIs, loggers, HTTP clients, caching services, and business services through the constructor. But developers must understand service lifetimes carefully because hosted services are singleton by default. That's where many production bugs begin.
We often see developers inject DbContext directly. Is that safe?
Usually, no. Hosted services are singleton services, while DbContext is scoped. Injecting a scoped service directly into a singleton creates lifetime conflicts and unpredictable behavior. Over time, this can cause memory leaks, stale tracking data, concurrency problems, or corrupted entity framework state. The correct solution is creating scopes manually using IServiceScopeFactory.
What's the correct production approach?
The safest production approach is creating a fresh dependency injection scope during every execution cycle. That gives us a brand new DbContext instance each time the worker runs and avoids memory leaks or tracking issues. This pattern is extremely important in long-running enterprise workers.
What if something crashes inside execute async?
Unhandled exceptions inside hosted services are far more dangerous than most developers realize. In a normal API request, an exception usually affects only one request. But inside a background worker, a single unhandled exception can silently stop the worker forever. That means critical systems like email delivery, queue processing, payment workflows, or scheduled cleanup jobs may completely stop running in production. That's why enterprise applications always use proper try-catch blocks, retries, monitoring, and structured logging. Some companies also implement automatic worker recovery and alerting systems, so failed workers restart immediately.
What if an external API temporarily fails?
Enterprise systems assume failures will happen constantly. Temporary network issues, rate limits, DNS failures, or slow external APIs are very common in production. That's why developers use resilience libraries like Poly to automatically retry failed operations safely. Without retries, temporary infrastructure problems can completely break your background processing pipeline.
What's the simplest scheduling approach?
The simplest approach is using task.delay inside a continuous loop. The worker performs its task, waits for a configured interval, and then automatically runs again. One important thing developers should remember is that simple task.delay scheduling can drift over time if processing itself takes longer than expected. For more advanced scheduling features like dashboards, retries, persistence, and distributed execution, companies often use Hangfire or Quartz.net.
What if I need many background workers?
Yes, absolutely. ASP.NET Core supports multiple hosted services running simultaneously in the same application. Each worker handles its own responsibility independently, which helps keep the architecture modular and maintainable. This is very common in enterprise APIs.
What common mistakes cause memory problems?
Background workers live for the entire lifetime of the application. That means even tiny leaks become massive after running continuously for days or weeks in production. One of the biggest mistakes is loading huge datasets into memory without patching. Another common issue is forgetting to dispose dependency injection scopes properly when repeatedly creating DbContext instances. Developers also accidentally create thousands of background tasks without throttling, which slowly exhaust memory and thread pool resources. Production-grade workers must carefully manage memory, batching, disposal, concurrency, and resource cleanup.
Are hosted services commonly used with message brokers?
Yes, this is one of the most common enterprise patterns. The worker continuously listens for messages from RabbitMQ, Kafka, or Azure Service Bus and processes them asynchronously in the background. This architecture allows APIs to stay lightweight while background workers handle expensive asynchronous workloads. In high-scale systems, workers also need back pressure handling so queues don't overwhelm the application under heavy traffic.
What if the background job performs heavy image processing or calculations?
This is where many architectures fail. Hosted services are excellent for IO-bound workloads like queue processing or API calls. But CPU-heavy workloads are very different. If heavy processing runs directly inside the web application, it can exhaust the thread pool and slow down the entire API under traffic. That's why companies often move CPU-intensive processing into dedicated worker services, microservices, Kubernetes jobs, or Azure functions. Keeping web APIs lightweight is critical for scalability.
What if multiple servers run the same hosted service?
That creates one of the biggest distributed system problems: duplicate execution. Imagine two servers processing the same payment or sending the same email simultaneously. Without distributed coordination, users may receive duplicate notifications or even get charged twice. That's why scalable systems use distributed locking mechanisms, leader election strategies, and coordination systems to ensure jobs execute safely only once.
How do companies know whether workers are healthy?
Monitoring is absolutely critical because background workers often fail silently. Unlike APIs, nobody is directly watching the process. A queue processor may stop running for hours before anyone notices. That's why enterprise teams monitor execution time, retry counts, memory usage, queue backlog, failure rates, and worker health status using centralized monitoring platforms. Without proper observability, background failures can silently damage production systems for long periods.
Are there situations where hosted services are not ideal?
Definitely, they are not always the best solution for short user-triggered tasks, extremely CPU-heavy processing, massive distributed scheduling systems, highly persistent workflow engines. Sometimes external platforms like Hangfire, Azure Functions, Kubernetes jobs, or serverless systems are better architectural choices.
Let's finish with your best practices checklist.
The biggest rule is this: background workers should behave like reliable production infrastructure that may run continuously for months in production. Always respect cancellation tokens so shutdowns happen gracefully. Never inject DbContext directly into hosted services because lifetime mismatches create serious production bugs. Always use proper exception handling, retries, monitoring, structured logging, and health checks. Background jobs should also be idempotent, meaning retries should not corrupt data or execute duplicate operations. If developers follow these principles carefully, hosted services become extremely scalable, reliable, and production safe.
Brilliant, Aarohi! Background services and hosted services are one of the most important architectural concepts in ASP.NET Core, especially for scalable enterprise applications. If this episode helped you, don't forget to like, comment, and subscribe to the .NET Way. In episode 18, we'll explore Signal R and learn how real-time notifications, dashboards, and chat systems work in ASP.NET Core. Thanks for watching. See you in the next one.